if you would. All right, so with multiplication, there's two different things that we should really be paying attention to as we work our way through multiplication. Number one, most important thing when you think about with multiplication is if I have two fractions being multiplied together, it doesn't matter what those two fractions are. You have to be, you have to understand that multiplying is 1,000% different than adding and subtracting. You do not have to have common denominators here, okay? So what a lot of people try to do is they try to get common denominators and they end up changing the problem and it's like bad things happen. Don't do that, okay? With multiplication, you multiply straight across the top and straight across the bottom. So straight across the top, straight across the bottom. 4 times 10 is 40. 5 times 2 is 10. And then this would just simplify down to 4, right? So that's one thing that you could do. No issue, no concern, no really big problems that are going to stem or show up here. But there is one thing that you can do first, okay? There is one little thing that you can do here if you'd like to, where if we take the exact same problem, we can make it a little bit easier. If I have 10 over 5 and 4 over 2, I could actually simplify the fractions on the left, I could simplify the fractions on the right, and I can actually cross simplify, okay? So what this means is I could take 10 over 5 and call it 2 over 1. I could take 4 over 2 and call it 2 over 1. And then I have 2 times 2 equals 4, 1 times 1 equals 1, and this thing is already simplified at the very beginning, okay? So there's two different methods to this approach. I think it's better to simplify first, because as you get to quadratics, as you start dealing with factors instead of dealing with numbers, it makes a little bit more sense to factor it right at the beginning, okay? Because, or to simplify right at the beginning. Because if you can simplify it at the beginning, you're going to make your life a lot easier in the long run. If you have everything completely simplified in the middle of the problem, that means there is going to be no simplifying necessary at the end of the problem, which is always a really nice thing. So I would suggest as you work through these problems, be very, very careful with your simplification. Simplify as early as possible, so that way you don't run into issues at the end of the problem, okay? If we're talking about general form, general form is when we have a over b and c over d, like we have just general fractions. I multiply a times c, and I multiply b times d, but there is a really, really important thing when you just introduce general stuff. There are absolutely no issues with my example originally, because my example in the original part was just concrete numbers. These numbers are not concrete, so there are going to be some restrictions. Is there anything that b cannot equal? 0. Is there anything that d cannot equal? 0. So you have to pay attention here that there are two numbers that can't equal 0, because if b or d equals 0, then instantly this problem is no good anymore. It's undefined, and if it's undefined, then we're toast. Okay? So that being said, you have to check two spots in multiplication to see if they equal 0. The two spots that you have to check are this spot here and this spot here. Okay? You have to say both of those spots, and you have to go through the math to say that that can't equal 0 and that can't equal 0. Okay? Because it's going to end up throwing off the entire problem. And if it throws off the entire problem, then that means that it's going to be undefined, whatever. If you put in the restrictions, and if you actually go through the work of finding out what numbers are okay or what numbers aren't okay, then you kind of saved yourself the rest of the problem. Division is done almost identically to multiplication. Okay? It's just copy dot flop. That's all it is. So if I have two numbers being divided, so like 4 over 2 divided by 3 over 6. If I have something that looks like this, this is the exact same thing as saying 4 over 2 times 6 over 3. And we've just turned it into a multiplication problem, and we just talked about multiplication, right? It is now literally the same exact problem as a multiplication problem. And if it's the same exact problem as a multiplication problem, there's really not much more that we have to do, okay? So if I simplify this, 4 over 2 will simplify to 2 over 1. 6 over 2 will simplify to 2 over 1, and 2 times 2 is 4. 1 over 1 is 1, so this would simplify down to 4 over 1. Okay? Now, this is the only difference between multiplication and division. This next thing that I'm about to talk about is the only difference. If I have things being divided, like a over b divided by c over d, we already know from the multiplication part that b and d can't equal 0, right? Because if you look at this fraction by itself, a over b, if you look at a over b, b cannot equal 0 because that fraction is then undefined, right? If we look at c over d, d cannot equal 0 because if d equals 0, this fraction is undefined. So right now, I can already say that b and d can't equal 0. But then I want you to realize that as you switch this into copy.plot, it turns into a over b times d over c, which means what else can't equal 0? C can't equal 0. So b, d, and c can't equal 0. So there's 3 spots to check when dealing with division. There's 2 spots to check with multiplication and 3 spots to check with division. These are the 3 spots. Okay? So as we work through, just make sure that you check all 3 of those spots and say that those things don't equal 0. It'll make a little more sense when we go through actual examples. But hopefully this is something that you can kind of see right now. If the denominator of a fraction is 0, it makes it undefined. If it's undefined, we can't do anything with it. Okay? If we take care of the numbers that would make it undefined and just bring attention to them saying this number can't be, or this fraction can't be 2, because then it would make it undefined. If we take that into account, then we're kind of saving ourselves in the problem, okay? So let's go through an example so that we can see what it looks like. And I'll try to run through and show you what we're looking at here. So you'll notice the first part says multiply by the reciprocal. That's only if you're dividing. You're only going to multiply by the reciprocal if you're dividing, so that step will not exist for the multiplication part. Okay, so this is only if you have division. If you don't have division, you don't need to multiply by the reciprocal. The next step is the most important step in this entire thing. Because if you don't factor the numerator and the denominator, you're going to create so much more work for yourself, it's not even fun. Okay? Factor it. Because when you factor it, you have to understand you're saving yourself time. Factoring allows you to cancel. Canceling makes life easier. Okay? So make sure when you're doing this, you're factoring the numerator and the denominator. The numerator of the left cannot be simplified or factored at all. The numerator, the denominator on the left cannot be simplified or factored at all. If you wanted to, I guess you could call it 3x times 3x. But most people probably wouldn't factor that because there's not much to do. Right? The thing on the right, what can I take out of the numerator on the right side? I can take out an x. Can I take out any more? 3x. Okay? So I can do that. Now, I'm just going to make a little picture over here, just in case. So, like with simplification, so if you're simplifying and you have a over b and c over d and you're multiplying, you can simplify here and here, or you can simplify here and here. So you can simplify across, like you're cross multiplying, you can simplify that way. Or you can simplify top and bottom of a fraction just like normal. Okay, so there's 4 spots you can check for simplification. You can simplify each fraction individually, or you can cross simplify. Okay, so that's just something in case you didn't remember. Okay, now an important part, because down here at the very bottom, where it says denominators don't equal 0, I'm going to put a little important note here. I'm going to say find denominators that can't equal 0 before you cross anything off. So find that what x can't equal, find what the x can't equal values are before you cross anything off, because those are the things like the holes, right? Those are the things that show up in the graph, and if you cross it off, it makes it look like it doesn't exist, and then you won't give that information, okay? So before you cross anything off, make sure that you find what x can't equal, okay? So right here, it says to cross out terms that are common in the numerator and denominators of both fractions. So this is where I start to simplify. Before I actually simplify, I'm going to find what x can't equal, okay? On the left side, there's only 2 spots that I need to check, right? The 2 spots that I need to check are here and here. There's 2 spots. So the 2 spots I have to check with multiplication are 9x squared and x. What is the only number that x can't equal that would create an issue? 0. So this is saying x can't equal 0. Every single other number is okay. Every single other number is fine. Okay? So every number is fine. Just kind of keep that in mind. So now we can start to cross off. There's 3 spots that we can cross off, right? The first one that I see to cross off is I could cross off this x and this x right here. I can also take a 3 out of the 9, and I can take a 3 out of the 3. So I can cross off this 3, it will become a 1. I can cross off this 3, it'll become a 3. And that 9, it'll become a 3. Okay? Now a really, really important thing, because this is going to pop up, do not simplify things that are inside parentheses. Okay? So you see how this x plus 1 is inside the parenthesis? You cannot cross that off with just a normal x. You can't cross 1 off with the 3. If it's in parentheses, nothing can be simplified unless it looks the exact same. And when I say that, I mean if it says x plus 1 on the top and it said x plus 1 on the bottom, I could then cancel those. But I cannot do x plus 1 over x. I can't simplify that. Okay? This one cannot be simplified at all, so don't even try it. Okay? So now, cross off the terms that are alike. We've crossed off the terms that are alike. Now I'm going to multiply straight across the top. Okay? So I'm going to get 7 times x plus 1 over, and I just have 3x squared left, so over 3x squared. So now what I'm going to do is I'm going to combine it into one fraction, which means that I'm probably going to have to distribute and combine all of my like terms. So in this case, it's not that bad because when I combine it into one fraction, it's going to be 7x plus 7 over 3x squared because that 7 is just getting distributed through the top. Now, sometimes you're going to have to refactor this after you've combined all your like terms because you might be able to cancel more stuff. But in this case, is there anything that can be canceled at all? Can I cancel anything? No. So there's no more factoring. So my answer is going to be 7x plus 7 over 3x squared. Okay. Now, while you guys are sitting here, the next question is a little bit trickier because there's more factoring that has to be done with it, and there's more stuff going on. So I want you guys to try that one right now, so that way, take a couple minutes on your own, and then we're going to go through it together to make sure that you understand the whole process of what's going on. Okay, so try that one directly to the right of this, and once you get done with the one to the right of this, we'll go through it together. So as we work through, again, obviously, this should have the first step where we would multiply by the reciprocal, right? So we're going to flip this, so it would end up being x plus 2 over 2x minus 2 times x squared minus 4x plus 3 over negative 2x minus 1. Now, obviously, the better you get at this, you don't have to write down every single step. If you want to factor and flip at the same time, then factor and flip at the same time. It doesn't matter. So the next step would be to factor, right? On the top left, we can't factor at all. So since we can't factor at all, I'm just going to leave it as x plus 2. On the bottom, I'm going to factor every single thing that I can. Okay? So if you can factor something even as simple as a negative out, factor the negative out. No matter what you can do, factor it. Okay? The top right is going to factor into x minus 1 and x minus 3. And then on the bottom left, I'm going to factor it out again. And so I'm going to do negative 2 times x plus 1. So no matter what I can factor, I'm going to try to factor. Okay? So no matter what, I'm going to try to factor. Now, right now, I'm at the point where I can start canceling. Before I cancel, I want to find what x can't equal. So I want to find that thing at the very, very bottom. Okay? So I want to find what x can't equal. There are 3 spots for me to check. Okay? 3 spots. Yeah.
Why is there x plus 1? Why is there a 1?
Because I factored a negative 2 out. Oh, I can't factor a negative 2 out of that, right? Good catch. I can't really, I could factor a negative out of there, though. So if I factor a negative out, I could do negative 1 and then 2x plus 1. Good catch. So I really can't factor anything out of the bottom. That was my fault. I thought that was 2. But again, you see that I factored everything out that I possibly could, right? I factored everything out that I possibly could. Now I'm at the point where I want to find out what x can equal. So if I want to find out what x can equal, there's 3 spots that I'm going to look. Spot number 1, spot number 2, spot number 3. 3 spots that I look with division, okay? So on the bottom left, right here, I'm finding out that x can't equal 1. Because I'm just saying if x equals 1, 1 minus 1 is 0, no good. If I look at the top right, 1 is still there. 1 minus 1 is 0, no good. X can equal 3 because of 3 minus 3. And then on the bottom left, or the bottom right, 2x plus 1 can equal 0. So if you actually have to go through the math and say 2x plus 1 can equal 0. So minus 1 minus 1. So you get 2x can equal 1 divided by 2 divided by 2. You get x can equal 1 half. Negative 1 half, right? So x can equal negative 1 half. Okay? So if I find out that x can't equal negative 1 half, that's okay. All right, so now we move on and we start to simplify whatever we can simplify. So right here, I see that there's an x minus 1 on the top right and an x minus 1 on the bottom left. Is there anything else here that's going to cancel at all? Anything at all that we see? Not really. So now I'm going to combine it into one fraction. So it's going to be x plus 2 times x minus 3 over, I'm going to combine the 2 and the negative 1 to be a negative 2 and then a 2x plus 1. Now this is the part that gets a little bit tedious because now you are going to have to, I guess you don't have to this time. So you see right here, if I were able to cancel something, I'll cancel it right now. Right? If there's anything left to cancel, cancel it. If there's not anything left to cancel, then don't. But realistically, as I look through this, this is the most basic factored form it could be in. This is the most basic factored form it could be in. There's nothing else that can be simplified here, so this is going to be my final answer. If you'd really like to, you can multiply it all out again. Okay? So if you really, really want to, you could multiply it all out, and you could call it x squared plus minus x minus 6 over negative 4x minus 2. If you wanted to, you could call it that. It doesn't make a difference, but the two important things are that you have one of the two things in circles, so either this one or this one. I don't care which one it is, and this is super important. So you have to have the x can equal it. Any questions you guys have got? Tomorrow is going to end up being a review day, like this stuff and new stuff, and we actually have our mid-chapter quiz on Wednesday. Enjoy your day.